It began as a day that should have gone down in history for its elegance, not its tragedy. A sleek white Aero, the Concorde, stood on the warm tarmac of Paris Charles de Gaulle Airport, shimmering under the afternoon sun. For more than 30 years, this aircraft had been a living symbol of human ambition, an engineering masterpiece that sliced through the sky faster than the sound it created. It had carried presidents, royalty, and the wealthy elite across the Atlantic in half the time of any other commercial jet. And on this July afternoon in 2000, there was no reason to believe that its reputation for near-perfect safety would be shattered in just minutes. For the 100 passengers preparing to board Air France Flight 4590, this wasn't just another flight. Many of them were German tourists, embarking on a once-in-a-lifetime adventure, a luxury cruise from New York to South America. Their day had begun with anticipation, excitement, and perhaps even the thrill of stepping aboard a technological legend. Very few aircraft in history had the allure of the Concorde. It wasn't simply transportation, it was an experience, a dream, something people spoke about for the rest of their lives. To understand the weight of what was about to happen, one must understand what the Concorde represented. Born from the unlikely partnership between Britain and France at the height of the Cold War, the Concorde was aviation's moonshot. When it first took flight on March 2, 1969, it wasn't just a plane. It was a promise that the future would be faster, more daring, more elegant. Its iconic delta wing, needle-like nose, and 4 roaring Rolls-Royce Olympus engines made it instantly recognizable, even to people who knew nothing about aviation. In an era when most jets cruised at 900 km/h, the Concorde soared at over twice the speed of sound. While others flew at 35,000 feet, Concorde sliced through the stratosphere at 60,000 feet, where passengers could literally see the curve of the Earth. And through all those years, despite tire bursts, bird strikes, and the intense stresses of supersonic flight, one thing remained true. No Concorde had ever suffered a fatal accident. Not once. Until today. The aircraft assigned to Flight 4590 was not the one originally scheduled. During the night, Air France maintenance had swapped the jet for another Concorde, a change invisible to passengers but significant for the crew. Early that morning, the dispatcher noticed an issue with one of the thrust reversers, a system used to slow the aircraft after landing. The problem was minor and legal under regulations, but it imposed a performance penalty. The aircraft might need to make a fuel stop instead of flying directly to New York. At first, the crew accepted this. Later, maintenance reported that the reverser had been repaired, and suddenly the plan changed again. They could now take enough fuel to cross the Atlantic non-stop. Those decisions added weight, and on a Concorde, weight mattered more than on any other passenger jet. Meanwhile, a separate problem was brewing at the check-in counters. A computer error caused several passengers and bags not to appear on the manifest. By the time the issue was corrected, the aircraft carried 19 more bags than originally listed. Again, more weight. Not enough to alarm anyone outright, but enough to push the aircraft close to its physical limits. The crew, however, was among the most experienced in the world. The captain, age 54, had over 13,000 flight hours, more than 3,000 of them on the Concorde. His first officer was a seasoned pilot and simulator instructor. The flight engineer, a veteran of nearly 12,500 hours, had spent years on the type. These were professionals who understood every nuance of the aircraft, from its graceful performance at Mach 2 to its demanding behavior during takeoff. Before departure, the crew performed their routine briefing. They discussed takeoff speeds, the heavy fuel load, the weather, and the slight performance penalty still affecting the aircraft. Nothing raised alarm. After all, This was a machine they knew intimately, trained for, practiced on, and flown countless times. Yet beneath the surface of this ordinary day, several small details were beginning to align in a way no one could foresee. A delayed boarding, a last-minute aircraft swap, a baggage discrepancy. Even the warm summer air and the slight tailwind that afternoon played their part in shifting the margins closer to the edge. Most viewers today know the Concorde as a technological marvel from the past. But for those who lived through the 1970s, 1980s, and 1990s, the Concorde was something more personal, a symbol of optimism, proof that engineering could defy nature itself. You didn't need to be an aviation expert to admire it. Watching it rise from the runway, nose drooping like a predatory bird, flames glowing blue from the afterburners, was enough to stir a sense of wonder. That's what makes the story of Flight 4590 so powerful and so haunting. Because it wasn't only the end of a single flight, it was the beginning of the end of an entire era. Passengers took their seats. Flight attendants closed the heavy, narrow doors. Luggage was loaded. Fuel tanks, 13 of them, were topped to capacity. The sun hung low over Paris, and as the massive Delta wing cast its shadow across the runway, the Concorde stood poised for yet another flawless performance. But this time, something was different. Something invisible, small and seemingly insignificant was waiting on the runway. Something that would intersect with the aircraft at precisely the wrong moment. The countdown to disaster had already started. For decades, the Concorde captured the world's imagination as mankind's boldest leap into commercial supersonic travel. Yet behind the prestige, the champagne, and the breathtaking speed lay a series of engineering compromises, brilliant, innovative, but also unforgiving. To understand why Flight 4590 would later lose its fight for survival in less than 2 minutes, one must first understand the Concorde's unique mix of power and vulnerability. The aircraft's defining feature, its majestic delta wing, was both its strength and its burden. Unlike traditional aircraft wings that generate strong lift even at lower speeds, the delta wing depended on tremendous velocity and a high angle of attack to lift the aircraft from the ground. On a typical commercial jet, takeoff occurs around 140 knots. The Concorde needed nearly 200. At that speed, the air hammered the tires with a force unmatched by any other passenger aircraft. Every takeoff was a battle between technology and the limits of physics. This pressure on the landing gear made tire performance critical and historically problematic. Over its 30 years of service, the Concorde experienced 57 tire bursts. Most were harmless, quickly forgotten incidents, but 12 of them caused structural damage as violent fragments of rubber shot upward with enough force to dent metal, break hydraulic lines, or pierce the underside of the wing. In 6 cases, those fragments penetrated wing fuel tanks. One such event, in 1979, nearly caused a catastrophe when a tire explosion ruptured a fuel tank on a takeoff from Washington, D.C., spraying fuel and damaging hydraulic systems. Only exceptional crew handling prevented a disaster. The investigation that followed recommended improvements: stronger tires, better hydraulic protection, more safeguards against fuel leaks. Some changes were made. Others were judged unnecessary or too difficult. Engineers argued that any fuel leak from tire debris would be minimal, unlikely to ignite. History, however, often has a way of proving confident assumptions wrong. Beyond its tires, the Concorde had complexity woven into every part of its structure. Its fuel system was unlike anything in conventional aviation. With 13 tanks distributed throughout the wings and fuselage, fuel didn't merely power the engines, it balanced the aircraft. Concorde didn't rely on traditional trim systems. Instead, Pilots pumped fuel between tanks mid-flight to shift the aircraft's center of gravity. During takeoff, for example, the goal was a precise 54% center of gravity, a number calculated to perfection. If it was even slightly off, the aircraft's delicate aerodynamics could change, demanding more lift, more angle of attack, more strain. The engines, 4 Olympus 593 turbojets, were technological treasures. Originally derived from military power plants, they were designed not merely for thrust, but for supersonic stability. Each engine featured variable geometry air intakes that reshaped the airflow as the aircraft transitioned from subsonic to supersonic speeds. Beneath those intakes were secondary inlet doors, crucial for feeding the engines during takeoff when airflow conditions were unpredictable. But these same secondary inlets created a vulnerability. Under certain conditions, they could funnel debris or hot gases straight into the compressors, something no jet engine tolerates well. When all went smoothly, these systems worked in harmony. The Concorde accelerated, ignited its afterburners, and climbed into the stratosphere with breathtaking grace. But when something went wrong, especially at low altitude, its hyper-optimized design left little room for error. The aircraft's performance margins were tight, much tighter than most passengers ever knew. A fully loaded Concorde on a warm day carried almost no excess runway length. Everything had to be perfect: weight, wind, tire pressure, engine temperatures, and the precise execution of takeoff procedures. A sudden loss of thrust on one side of the aircraft would create an enormous asymmetry. A burst tire could become a projectile weapon aimed back at the wing. A small deviation in speed or angle could force the pilots into aerodynamic territory where the delta wing struggled to produce lift. And on the day of Flight 4590, those margins were already narrowed by a series of small decisions: extra baggage, increasing weight, warm summer air reducing performance, a tailwind affecting rotation speed, a nearly full fuel load stretching the aircraft close to its structural limits. The flight engineer and captain calculated everything as required, but reality had drifted closer and closer to the edge of what Concorde could handle. What made these vulnerabilities so difficult to address was that they were intrinsic to the aircraft's design. The same features that allowed Concorde to soar at Mach 2 also made it unforgiving during its most critical moments: takeoff and landing. Engineers, pilots, and regulators understood those risks. They accepted them. After all, the aircraft had proven itself for decades, surviving tire failures, hydraulic problems, and even lightning strikes. Each time, the Concorde demonstrated remarkable resilience. But resilience is not invincibility. As Flight 4590 prepared for departure, another aircraft, Continental Airlines Flight 55, was lining up on the same runway. Minutes before the Concorde's takeoff, a metal strip fell from one of the DC-10's engines onto the center line. It was a slender piece of titanium alloy, just 43 centimeters long. The DC-10 crew had no idea it was gone. Air traffic control didn't know it had fallen, and no one on the ground had any reason to believe a foreign object lay waiting on the runway. That strip was small, unremarkable, easy to overlook, yet it was enough to turn Concorde's vulnerabilities into fatal weaknesses, enough to convert decades of improbable safety into the deadliest moment in the aircraft's history. The Concorde stood at the runway threshold, engines ready, fuel balanced, the crew focused. They knew that takeoff would be intense. It always was. They knew the aircraft needed power, precision, and speed. But they could never expect what was about to unfold. All the engineering marvels, all the innovations, all the compromises Concorde carried into the sky were about to be tested in the most unforgiving way imaginable. And the test would begin the moment its wheels touched that forgotten piece of metal. The hours leading up to the takeoff of Flight 4590 were filled with the kind of routine activity that makes aviation feel predictable, almost comfortable. Crews inspected aircraft, ground vehicles moved luggage across the ramp, and passengers drifted through the terminal, unaware that timing, weight, and chance were quietly aligning into a catastrophic chain. Nothing in those final minutes suggested the Concorde was about to face the most dangerous takeoff of its existence. At 14:25 local time, after a series of small delays, the Concorde crew received clearance to start the engines. This moment marked the beginning of a sequence that normally brought excitement, a roar of raw jet power, the promise of supersonic flight, and the thrill of lifting off in a machine capable of outrunning its own sound. But on this afternoon, those engine notes masked a subtle and escalating tension. The aircraft had been fueled heavily, 95 tons, bringing it close to its maximum allowable takeoff weight. The crew discussed this during their pre-flight checks, fully aware that the heat of the day, combined with the aircraft's weight and a slight tailwind, reduced their safety margins. But nothing exceeded regulations. Nothing required them to reconsider. Out on taxiway Romeo, as the Concorde rolled toward runway 26R, the first officer noticed something odd. The electrical control system for the rudder kept switching itself into a backup mode. He called the engineer's attention to it, and after a short discussion, they agreed it wouldn't affect the flight. It was a dispatchable fault, one that had been seen before and categorized as non-critical. Still, the moment added a faint note of uncertainty, the kind pilots mentally acknowledge but push aside as they continue their preparations. Meanwhile, something else was happening far ahead of them, something the crew could not see. Continental Airlines Flight 55, a DC-10, was accelerating down the same runway. Seconds after liftoff, a small titanium strip, improperly installed during maintenance, detached from the engine structure and fell onto the center line of the runway. The DC-10 soared out over the horizon, unaware of what it had left behind. For any other aircraft, this piece of metal might have caused no more than a damaged tire. But for the Concorde, flying at extreme speeds with a history of tire vulnerabilities, it was a hidden threat waiting silently on the asphalt. Back in the cockpit of Flight 4590, the flight engineer computed the taxi fuel burn. They had expected to use around 2 tons before reaching the runway. Instead, they had burned less than half of that, only 800 kilograms. The discrepancy mattered, because it meant the aircraft was not just heavy, it was now heavier than planned, just slightly above its certified maximum takeoff weight. The engineer mentioned the number. The crew noted it, but continued. They had taken off with similar weights before. Nothing suggested this was a reason to abort the flight. The captain performed his final takeoff briefing, walking the crew through the standard procedures. They discussed their V-speeds, V1, VR, V2. They discussed what failures would justify rejecting the takeoff and what failures they would be committed to handling in the air. The first officer would monitor instruments. The captain would control the aircraft. The engineer would manage systems and engines. It was a textbook briefing, the kind the crew had done countless times. Yet, buried within it was a telling detail. Because of the Concorde's history with tire bursts, the crew included tire flash as grounds for aborting the takeoff above 100 knots. That single phrase revealed how aware they were of this aircraft's greatest weakness: rubber, meeting the runway at nearly 200 knots. Moments later, the aircraft reached the runway threshold. The control tower offered an intersection takeoff, an option that would have shortened the rollout. The captain declined. With their weight, they needed every meter. The Concorde turned onto the center line facing west. The sun flashed across its long, slender fuselage. The flight engineer called out brake temperatures, about 150 degrees Celsius, equal on both sides. That symmetry would later prove crucial to investigators, confirming that the landing gear alignment was normal. Then came a detail that, in the rush of takeoff preparations, slipped past unnoticed. The tower reported the surface wind, EUO 90 degrees at 8 knots. A tailwind. Not a strong one, but enough to raise the aircraft's required ground speed by several knots. Enough to push the Concorde's already high rotation speed closer to the limits of what the tires could handle. Enough to reduce the runway margin even further. Had the crew recalculated their numbers at that moment, they might have discovered they were now above the certified maximum takeoff weight for the given conditions. But time was short. The runway was clear. The passengers were ready. At 14:42:30, the captain pushed the throttles forward. The Olympus engines responded instantly, igniting their afterburners with a fierce, unmistakable rumble. Flames stretched behind the aircraft like four blue swords. The Concorde surged forward, gathering speed with the raw, unrestrained aggression of a machine built to break boundaries. It was now accelerating directly toward the metal strip. With every passing second, the aircraft was moving faster, the tires taking more punishment, the aerodynamic forces rising. Behind the cockpit windows, the captain and first officer focused on the runway center line, scanning for cues, monitoring speed, listening to the steady call-outs. 100 knots, 4 greens, everything normal. But normality was an illusion lasting only moments longer. They were seconds away from the point where a routine takeoff would become a fight for survival. Seconds away from hitting a piece of metal no bigger than a household ruler. Seconds away from an explosion that would rip open a fuel tank, ignite a fire, and cripple half the aircraft's engines. At this moment, these final, calm seconds, the crew still believed they were flying the safest supersonic airliner in the world. They still believed they were in control. In truth, the disaster had already begun. At 14:42 and 35 seconds, as the Concorde thundered past the midpoint of runway 26R, destiny revealed itself in the form of a sharp metallic impact. The left main landing gear struck the fallen titanium strip from the DC-10. For a fraction of a second, nothing seemed unusual. No sudden jolt, no alarming vibration. But within half a second, the disaster unfolded with brutal clarity. A violent explosion shattered the calm inside the cockpit. One of the tires on the left landing gear burst with tremendous force, sending fragments of high-density rubber, each weighing hundreds of grams, hurtling upward at nearly the speed of a bullet. These shards slammed into the underside of the left wing, directly beneath fuel tank number 5. The impact was so forceful that the metal skin of the wing did not simply dent. It buckled inward, compressing the fuel inside like a piston slamming into liquid. The result was a pressure wave that surged through the tank with nowhere to escape. It ruptured outward from inside. Investigators would later find that the tank had burst like an overinflated boiler, sending fragments of aluminum scattering across the runway. Instantaneously, dozens of liters of fuel began gushing from the torn metal, spraying into the slipstream and onto the landing gear. In the turbulent airflow behind the wheels, the mist of fuel ignited, likely triggered by electrical arcing from damaged wiring in the gear bay. In the cockpit, the first sign of trouble was a sudden, unexpected yaw to the left. The first officer corrected with rudder, instinctively compensating, but before he could fully assess the situation, the flight engineer shouted the words no Concorde crew had ever wanted to hear: "Watch out!" Simultaneously, the engine monitoring lights for engines 1 and 2, both on the left side, began to flicker. Their afterburners sputtered. The engines were choking on a deadly combination of hot gases, burning fuel, and rubber debris. Just 4 seconds later, the aircraft's airspeed reached 178 knots, still below rotation speed, but with the left side engines losing thrust, The Concorde was drifting off the runway center line. The captain, realizing they were seconds from veering into the grass, made a desperate decision. He began to rotate early. It was a choice made not out of procedure, but survival. Staying on the ground meant running out of runway with a burning aircraft. Lifting off was the only remaining option. The rotation was sluggish, far slower than normal, because the aircraft lacked the airspeed it needed. The nose rose reluctantly, dragged upward more by necessity than aerodynamic grace. The flight engineer, sensing disaster, called out something that sounded like "stop" on the recording, though unclear. But it was too late. They had passed V1. A rejected takeoff at that speed would have guaranteed a catastrophic overrun. As the Concorde left the runway, its landing gear struck several runway edge lights. The aircraft clawed its way into the air, just barely flying. Flames trailed behind the left wing like the exhaust of a rocket, lighting the ground below in an orange glare so bright that witnesses miles away would later describe it as a torch in the sky. Inside the cockpit, warnings multiplied. The fire alarm for Engine 2 blared. The flight engineer initiated the shutdown procedure. Throttle back, fire handle pulled, fire bottle discharged. But the fire wasn't in the engine. It raged outside, feeding on the torrent of fuel still streaming from Tank 5. Shutting down the engine did nothing to extinguish the inferno. The first officer called out, "Speed, speed," as the aircraft struggled to accelerate. After takeoff, Concorde required at least 220 knots to maintain a safe climb. They had barely 200. The Delta wing, elegant at high altitudes, was unforgiving in low-speed flight. The aircraft was hanging on the edge of aerodynamic stall. The captain commanded the landing gear up. The first officer hesitated. Standard procedure required keeping the gear down if damage was suspected, but the captain insisted. The first officer tried to raise the wheels, but the mechanism refused to respond. The explosion had likely jammed or warped the gear doors. With the landing gear locked down, drag increased significantly, and the fire continued to burn undisturbed behind it. The situation deteriorated with terrifying speed. Engine 1 surged, its compressor disrupted by the chaotic airflow and flames entering the secondary inlets. Thrust dropped again. On the right side, engines 3 and 4, now in contingency mode, produced maximum power, but it wasn't enough to counter the imbalance. At barely 100 feet above the ground, the Concorde was flying with only 2 functioning engines and a massive fire eating into the wing. The crew tried to turn toward Le Bourget Airport, the nearest suitable landing field. But as the aircraft banked, the burning fuel weakened the internal structure of the wing and began melting the inboard elevon, one of the essential control surfaces for roll. The first uncommanded roll began. The captain fought it with everything the controls could give him. For a moment, the aircraft leveled. But then Engine 1 surged again and lost almost all remaining thrust. The asymmetric forces became overwhelming. The aircraft rolled hard to the left, 60 degrees, then 90, then 113 degrees. The horizon tilted in the cockpit windows until sky and ground traded places. The GPWS screamed, "Pull up! Pull up!" The captain pulled, but the nose was already dropping. The Concorde, engulfed in flames, sinking in a left wing down spiral, had no lift left to give. At 14:44 and 31 seconds, 121 seconds after the tire struck the metal strip, the Concorde slammed into a small hotel in the town of Gonesse, just beyond the airport perimeter. The explosion shook the surrounding streets. All 109 people on board perished instantly, along with 4 people on the ground. What had been a routine takeoff became the deadliest moment in Concorde's history. And in that brief, violent span of time, the aircraft's greatest strengths, its speed, its power, its sophisticated engineering, were no match for a single piece of metal and an airframe pushed beyond its limits. The era of supersonic passenger flight had just met its beginning of the end. In the chaotic hours that followed the crash, while smoke still curled upward from the wreckage in Gonesse and the world attempted to process the unthinkable, the loss of the first and only Concorde in a fatal accident, investigators from the French BEA moved quickly to secure the crash site. The wreckage lay in an area no larger than a city block. The fire had consumed much of the fuselage, leaving behind charred metal, fragments of wing, scorched wheels, and the shattered remains of what had once been the most advanced passenger aircraft ever built. The site was somber. Witnesses who had watched the flaming aircraft struggle in the sky gathered behind police lines, shaken, whispering in disbelief. For decades, Concorde had been synonymous with safety, precision, luxury. Many thought it was nearly indestructible. Now its remains lay scattered across a Paris suburb, and the world demanded answers. The search for the first clue. Almost immediately, investigators noticed something strange about the left main landing gear. One of the spacers, a key metal component that ensured perfect alignment of the wheels, was missing. Engineers and pilots knew how critical wheel alignment was for high-speed operations. A misalignment could have added friction, heat, or structural stress. Had this missing part contributed to the disaster? For 48 tense hours, the media speculated wildly. Had Air France neglected crucial maintenance? Had the Concorde been unsafe all along? Then the truth emerged. The missing spacer wasn't lost during the accident. It wasn't somewhere on the runway. It was sitting in a maintenance workshop. Air France personnel had removed it during repairs, but had never reinstalled it. A serious oversight, yes. But as investigators studied the runway marks, acceleration values, and brake temperatures recorded before departure, they concluded the landing gear had been perfectly aligned throughout taxi and takeoff. The spacer was a maintenance failure, but it was not the cause of the crash. Turning attention to the runway. Once the spacer was ruled out, investigators shifted their focus back to the runway. They found unmistakable evidence: shards of tire debris, a bent water deflector, and, most crucially, a long thin piece of titanium alloy. It matched the support strip that had detached from the Continental DC-10 minutes earlier. This discovery changed everything. The strip was not only improperly maintained, it had been drilled with far more holes than the manufacturer allowed, weakening its structure. Engineers at Continental Airlines had modified it without proper documentation. It was, in the eyes of French prosecutors, a ticking time bomb. The BEA concluded that the Concorde had not failed on its own. Instead, it had been brought down by a chain reaction triggered by foreign object debris, the kind of hazard airports work tirelessly to prevent. Yet on that day, French runway inspection standards required only 2 daily checks. There was no mandatory sweep after each heavy departure. The strip lay unnoticed on the runway, waiting. A tire burst. Unlike any before tire bursts, were nothing new for Concorde, but this one was different. Never before had a burst caused a fuel tank to explode outward. Investigators studied the wing's metal structure, thin for weight reduction, flexible, and designed to withstand aerodynamic loads, but not the concentrated impact of high-speed debris. When the heavy rubber fragments punched into the bottom of Tank 5, they created a shock wave that ripped the tank apart from the inside. It was a catastrophic failure scenario that earlier design reviews had underestimated. The aircraft had no fuel tank liners, no Kevlar reinforcement, no internal barriers to prevent fuel from flooding outward in seconds. Inside the fuel tank, the engineers of 1969 had never imagined such a violent chain of events. But 21st century investigators now understood it with painful clarity. Could the crew have saved the aircraft? As the technical explanations emerged, attention turned toward the cockpit. The public wanted to know, had the pilots made mistakes? Had they reacted too slowly? Had they rotated too early or too late? The BEA replayed the cockpit voice recorder again and again. They mapped the aircraft's trajectory from the first tire burst to the final loss of control. They studied the engine stall patterns, the asymmetric thrust, and the aerodynamic forces acting on the crippled airframe. Their conclusion was firm. There was nothing the crew could have done to save the aircraft. Once the fuel tank ruptured and fire engulfed the engine area, Concorde lost nearly half of its thrust. With landing gear extended, drag increased dramatically. The delta wing, unforgiving at low speeds, provided no margin for recovery. Even if the captain had attempted a rejected takeoff at the moment of the tire burst, the aircraft would have overrun the runway and exploded with the tanks already burning. The crew made every correct decision available to them. They acted with discipline, skill, and courage in circumstances no training scenario had ever prepared them for. The legal aftermath. The question of blame ignited a transatlantic courtroom battle. French authorities charged Continental Airlines with involuntary manslaughter, arguing that the faulty titanium strip had directly led to the crash. They also accused a mechanic of installing the part improperly. Continental countered fiercely, claiming Concorde was inherently unsafe and accusing Air France of failing to maintain its own fleet. They argued that design flaws, not a piece of metal, caused the tragedy. Years of litigation followed. In 2010, a French court found Continental partially responsible, issuing fines and symbolic damages. But the decision remained controversial. Aviation experts worldwide disagreed. Some argued the Concorde should never have flown without fuel tank reinforcements. Others insisted no commercial aircraft could withstand the forces Concorde faced that day. What remained indisputable was that the disaster forced the world to confront the risks of supersonic travel. The grounding and the attempted revival. Immediately after the crash, the aviation authorities grounded the entire Concorde fleet. Engineers from both British Airways and Air France collaborated to redesign the aircraft's weak points. They installed Kevlar lining inside the fuel tanks, material strong enough to contain shock waves and debris. New Michelin tires were developed, capable of resisting catastrophic bursts. Electrical systems were rerouted and protected. Procedures were tightened. The improvements were significant, expensive, and long overdue. By late 2001, after more than a year on the ground, Concorde took flight again in a symbolic return. Fans of aviation celebrated. Many believed the tragedy had been addressed and that the dream of supersonic travel could continue. Then came September 11, 2001. Almost overnight, business travel collapsed. Passenger confidence plummeted. Aviation entered a harsh winter, and luxury flights were among the first casualties. Maintaining Concorde had always been expensive. Now, with fuel prices climbing and demand shrinking, the aircraft became financially impossible to sustain. In April 2003, British Airways announced it would retire Concorde. Air France soon followed. The final flight took place on October 24, 2003. Thousands gathered around Heathrow Airport. People lined rooftops, bridges, and streets to watch the last landing. The sight of the white Delta wing descending for the final time carried an emotion that words struggle to capture: nostalgia, admiration, and a deep sense of loss. The age of civilian supersonic travel had ended, legacy of a fallen legend. 2 decades later, the Concorde remains a symbol of human ambition, flawed, magnificent, unrepeatable. It represented a moment in history when nations dared to push beyond the ordinary and imagine a world where oceans could be crossed in 3 hours. The crash of Flight 4590 did not erase that legacy, but it did reveal the cost of innovation when safety margins tighten and oversight slips. It reminded the world that even the most advanced machines can be humbled by a small piece of metal, and it underscored a truth aviation professionals know well, that safety is never a finished achievement, only a perpetual pursuit. The Concorde now rests in museums. Its story is told through polished aluminum, fading flight manuals, and memories of the thunderous roar of afterburners. Yet the tragedy over Gonesse remains a defining chapter, a reminder that history's greatest triumphs can be fragile, and that even legends can fall. Flight 4590 was the beginning of the end, but it ensured that the lessons of supersonic flight would never be forgotten.